We're going to finish our notes on 10.03 and we're going to start solving equations. So let's go to page 10. We're going to expand, or we're going to follow the directions here, either expand, condense, or solve. And then once we go through our work, then we can match the correct answer choice, either answer choice A or answer choice B. So go ahead and work through those, and I'll go through the steps with you guys. I'll also show the answers as you guys work through. Basically, anything in the numerator is going to be part of a positive log expression. Anything in the denominator is going to end up being part of a negative log expression. Divided by 4 is taking a 4 by 4. I can push that 1/4 out in front. The condensing just means bringing my coefficient up as an exponent. Okay, condense, take care of the coefficients first, and then we can put them into their right spots. So M is part of a positive log. This goes up top. R is part of a negative log that goes below. U is part of a positive log that goes above. M to the 1/2 is taking from M. Expand. Expand means bring all the exponents down. Oh, yeah, yeah. Okay, okay. Okay. 1/5 root of z squared is the same thing as z to the 2/5.
bring that 2/5 down in front. Same thing as putting that 5 in the denominator. Okay, condense. My A and my A and U values are going to be the x plus 3 and x plus 2. I'm adding the two logs together. So if I'm adding two logs, I can make it into the product of two terms. Log of A plus log of B is equal to log of C plus log of D is equal to log of C times D. So I'm just taking SD and D multiplying together, and if I multiply this through even further, it'll end up being x squared plus 1x minus 6. Number 7, what's equivalent to 5 to the x equals 100? We know that anytime we're dealing with logs, we are trying to get the exponent by itself. So the exponent is by itself. The base is 5, so log base 5 of 100 is equal to f. Should be able to get from this log form back to exponential form as well. Base 5 raised to the exponent, x equals 100. So it's always good to see if you can work your way back to your beginning. That way, this helps confirm that you're on the right track, that you made the correct adjustments with your expression. Okay. I want to get this into a log form. So I want the exponent 2 by itself on one side of the equation. So log base e of x equal to 2. And log base e is same thing as saying what? Natural log. Yeah. So they are interchangeable. This is just a shorthand form of writing it, but this is more descriptive. So, what's equivalent to log base 3 of 3 to the 2x? So we'll set this equal to x. Let's see if that helps. 3 raised to the x is equal to 3 to the 2x. So x is equal to 2x.
Yeah, to like solve, where do you think, we're like the dog. Yeah, so right now we're building the basics. Eventually we're gonna have to do the solving, so solving is gonna take more time. We'll do a little bit of that today, but I want us to do a bit more review. And let's go to page 11. Okay, go ahead and expand out each of the terms, and then match with the choices, and then you can put the letters down, and that's gonna
answer that riddle there.
Okay with 1, 2, and 3.
Okay, any questions? And we're just going to do the first page of page 12 of 10.04, just to kind of get us started, but we can finish the rest tomorrow. But any questions with this? Give you another minute. And then start things off. Okay, so when we're solving these exponential equations, the idea is that if we can get the bases to match, then the exponents can just be, then we just focus our attention on the exponents. But before we can solve the equation, we're going to have to find a way to get the bases to match. And the key thing is to try to uh, find the smallest or find a number that both sides can be raised from. So typically we are trying to shrink both sides down to a common number with the same base. So the bases must be the same. If the bases are the same, then we can just remove the bases and just set the exponents equal. So for instance, if I have 32 to the x plus 3 is equal to 4 to the 2x plus 10. The idea is I would like to set the exponents equal, but my bases are not matching. So what's the common base that both 32 and 4 can share? 2, right? And 32 is 2 to the what? 2 to what power is 32? 2 to the fifth, okay? So I'll replace 32 with 2 to the fifth, and then I'm going to keep all the exponent that is on my original left side. 4 can be written as what? 2 to the second. So replace 4 with 2 to the second, and then write out your remaining exponent. Now the 2's can be removed, and I'm just focusing my attention on solving that equation. What's a common base that we can, have both sides start from? Three, yeah, three. So we got, I know that 1/3 feels weird, but we know we can always flip that 1/3 using negative exponents. So, yeah, we can always, so 3 is a good base to start from. 1/3 is same thing as 3 to what power? To the -1. Okay, so basically a negative exponent allows that number to flip to the other side of the equal sign.
I think it's 1/2.
Not quite, well, if it was 3 to the 1/2, that would be square root of 3, yeah. A negative is going to allow that number to flip to the other side. So 1/3 is same thing as 3 to the -1, and I want to keep my original exponent, so I will keep that 2x. 81 is 3 to what power? 4. And then keep my original set of exponents. Now the 3's can drop out. And just focus my attention on my exponents.
Is 81 1/3 the -1?
You made 81 into what? It has to be 1/3 to the -5 power. I'm sorry. No, wait, you're right. 3 to the 1/3 to the -4. That should still work here. You got 2x equals to -4. Oh, x equals positive. Sorry, you're right. -6x. Sorry, +2. My bad. +2. So if I can get two exponents, two bases to match, I can drop the bases and set the exponents equal. Likewise with log functions. If I can get two logs with the same base to match, I can just drop the logs and just set the values equal to each other. So number 3, log base 4. Now everything's log base 4 and all that is good, but the issue is that we have to clean up that right side first. We want to get that right side down to just one log expression. That's right, condensing. Product property, right? Log of A plus log of B equals the log of A times B. So now I can drop both sides. They both are sharing log base 4. I can remove log base 4 from both sides. And I'm just left with x equals 3x minus 3x minus 2. Okay. So I'm going to solve for x here, bring everything over to one side. So there's something called extraneous solutions, and that is where a solution may not stand because it can't fit into the original equation. So a log expression can only handle a positive value overall. So if any x value causes an expression to produce a negative log value, then that's an extraneous solution because logs can only take in a positive value. All right, so now let's talk about problems that require a little bit of help from the calculator. Now, on your calculator, you have log base 10 and log base e that are available for you to use. So if you see on your calculator, Go ahead. So you see there's a natural log button, right? And if you hit that natural log twice, log will show up. So your calculator can handle log base E. It can also handle log base 10. Right, so, huh? Let me get back to you on that. I thought it wasn't, and then now I need to go back and check. Okay, so number 4 here, 4 to the x is equal to 1.5. I want to solve for x, but x is stuck as an exponent, and the easiest way to solve for a variable exponent is to involve logs. So what I'm going to do is I'm going to take the log of both sides. I want to introduce logs into the problem. And the reason why is because if I can have logs in the problem, the exponent is free to move. Normally, we can't just move the exponent around without changing the value. But if it's part of the log expression, have that ability. Now that we have the log of both sides, this exponent is free to move. And once it comes down, it becomes a lot easier for us to work with because we now have some operations that are available to us that before was difficult for us to. Now that x is in front, now this becomes a multiplication problem. If I want to solve for x, I can just do what to both sides. Divide both sides by log of 4. So x equals log of 1.5 over log of 4. If you didn't have a calculator, then you would usually answer like that. Okay. But we have our calculator here. We'll do log of 1.5. Again, your calculator, you don't see a base there, but it's understood it's base 10. Um, there are some like terms that we can do first, so let's deal with the like terms, clean the equation as far as we can go, and then we can decide if logs can be helpful for our problem. So I can combine some like terms there, 16.9 minus 2.5. You can take log of both sides or natural log of both sides. Either way works. Usually with E, we like to do natural log because there's a nice canceling out process. Let me show you natural log first, and then I'll show you log to show you that you can do it either way. But there's something nice about natural log and E in the sense that they are kind of related. So they allow for things to clean up a little easier. So if I take the natural log of both sides, I can bring that exponent down. Remember, natural log is just log base E. The nice thing about natural log of E is if you enter this in the calculator, it's just equal to 1. So that goes away quickly for us. If I wanted to solve for x, I can divide both sides by 2. I do want to show you that we can do the same thing by taking the log of both sides. If you want to do that, you can do it. I'll share my screen a little bit. Sometimes there may be no solution. If you get a negative number, that's definitely no solution. So if you want to take a log of both sides, you can. It's just natural log allows things to clean up a little. It's not, I mean, it's not that much. It's just a little bit cleaner, but either way works. Let me double check. Now to get to the E button, you can just hit E to the first power. And that's the same thing. Wait, too long to read that down. Same time, too, same time. Okay, we'll do one more, number 6. This one's a little messier, but let's go ahead and take the log of both sides. But we do want the exponent to make its way down. Right now, it's hard to get the 6 and 5 to show the same base here. So now that we are in under the umbrella of logs, that exponent can now come down to a plus. Just be careful, if you bring that 2x plus 4 and negative x plus 1, set it apart with a set of parentheses. We want to solve for x, but we have all the logs sitting there, so we got to distribute all the way through, combine like terms. Not hard, but it just feels like an extra layer of messiness that we have to go through. Together. Log x values on the other side. Factor the x out and then divide it over to the other. Factor the x out. Rest is just go to the calculator. Sorry, I said that negatives are not good. Negatives aren't good if it's part of a log expression. Like you can have negatives with exponents and with log. If you want to get started with this section, we'll pick up tomorrow and just try to stay half a day ahead. All right, so we phone. You don't like to the mic, yeah.